Hey everyone, good afternoon. So I'm Ed Tang, the CTO and founder of Avegant, and today I'm going to talk to you a little bit about mixed reality display technologies, and specifically around a technology called the light field technologies. The first thing to recognize is, as Mike was talking about just before, is there's this trend where we've seen computers move to mobile platforms, and now we're seeing the beginning of mobile platforms moving toward wearable computing or ambient computing. This is something that we've always seen when I started this company about 5 years ago, that this trend toward wearable computing is coming, and it's coming faster than ever before. And it's really exciting to see what some of the technologies that are about to hit the market. And what we do in Avegant is we focus on creating new experiences by building new display technologies, particularly with a focus around human physiology, or how our vision actually works. My background actually is in the MEM space, but specifically around biomedical devices. And we think about display technologies in a way that, how do you make displays that are more compatible with your human vision? It's not just taking a panel full of pixels and strapping it to your face, that we've seen a lot in the last few decades, but rethinking this approach. And we started this by thinking about the screen, or actually getting rid of the screen. The first technology that we developed was a retinal projection display, where we took low-powered LED lights and we'd modulate it with a fully digital micromirror array. And these tiny mirrors would flip around, and they'd pick and choose which colors of light to project directly onto your retina. And that sounds a little bit scary, but actually it's a lot closer to how we naturally see. So when I look out into this room, I'm not seeing glowing pixels everywhere. I'm seeing light reflecting off of your faces, and that light actually is coming into our eyes. So we're taking these steps to get closer and closer to how vision actually works. And there's some really great advantages of this retinal projection technology, and I think you're going to see more and more of this in future products to come. But one thing you'll notice is it's extremely high resolution. Because we don't have traditional pixel structures, you don't get pixelation. So no screen door effects, no pixelation. In fact, we can deliver higher resolution with less pixels, reducing things like power and compute power. Extremely fast frame rates, extremely low latency. And we actually deployed this technology about 2.5 years ago in a product called the Glyph, which some of you may have seen before. And the Glyph is all about super high quality mobile media. And it's the first consumer retinal projection device ever shipped out into the market. And you can see some of the awards that we won, as well as being on Jimmy Fallon. And there's Jimmy seeing the future. We also have developed a lot of interesting experience in the manufacturing side of things, where we're not just developing technologies or prototypes, we're actually taking prototypes and building them in mass manufacturable ways, actually taking these cutting-edge new display technologies and bringing them to market. But coming back to the mixed reality space, the question that people are asking is, what is it going to take to make these devices more prolific? What is it going to take to make these devices better experiences? And light field is a key to that. So a lot of you probably have heard of light field, and some of you may have not. So the problem with displays today is all displays are fixed focus, including the displays that are in front of me or the transparent augmented reality displays that you put on. Now the problem with that is these displays, because the focus is fixed at a certain distance, you can only show objects that are around that distance. So if I try to build this experience, if I put my hand out and try to put a virtual object so it's sitting in the palm of my hand, what you notice is that it doesn't look right. The focus of the object never matches the focus of my hand. And this is a problem with all AR and mixed reality devices today. And what that causes is two major problems. First is very unrealistic overlay, where it doesn't look like it's in my hand. It looks like it's kind of out there somewhere. And it also makes you really uncomfortable. In fact, can make you sick. Different kind of sickness in augmented reality than it is in VR, but sick nonetheless. And there's some real scientific and biomedical reasons why this is true. So if I take you down a little bit of a scientific journey here, the first thing I'll talk about is, how do we see depth? What's interesting is we all use our vision all the time, but we don't actually spend a lot of time thinking about how our vision actually works. So if we take a moment and think about, how do we see how far an object is? What you find is that there is many different depth cues. There's things like size, where an object is really big, it's probably close to me. If an object moves farther away, it's probably smaller. Same thing with motion parallax. So if I move left and right, objects that are close to me are moving a lot in my field, and objects that are far away from me stay relatively still. The one that people tend to focus a lot on in our space is accommodation and convergence, Where convergence is what we know as kind of the angle of your eyes. That's what we observe when we put on these 3D glasses in a movie theater. But the other one is accommodation, which is also known as focus. All of these depth cues need to match each other, and that's really important. And if any of these depth cues don't match each other, then your brain goes, that's wrong, I don't like it, this experience doesn't look correct to me. So matching these is really important. Specifically, getting focus correct is the biggest challenge today for displays. So what happens when the focus is wrong, right? This is the experience that we all have today. In almost every single head-mounted display, you have focus error. Well, if you look at the real world, everything is correct. And you can see that's this diagonal line here. It turns out we can actually tolerate quite a bit of focus error. But we can only tolerate this error far away. The second that you want to get in within about a meter or so basically almost within hand's reach, focus becomes really critical. It needs to be very accurate, or else you get those problems. Things don't look correct, things make you feel sick, gives you eye strain, headaches, nausea, and those are big problems. So our solution is we've created a new way to generate a light field. We've actually generated a multifocal plane display where we can simultaneously display multiple focal distances at the same time. And this becomes a really close approximation of how we see things in the real world, where when I look at an object in front of me, that object is clear and in focus, but simultaneously I can see things that are behind and in front. And it turns out it's not just what is in focus that matters, what's out of focus is also really important. And that previous experience that you saw before, where I'm holding an object in my hands, now looks correct, where I can actually have an object, it looks like it's in the palm of my hand, and simultaneously, I can see objects in the background. And just like in the real world, my eyes can very naturally shift focus between these 2 points, or multiple points. And it turns out, when you have this type of experience, objects feel very realistic. It's almost imperceptible from the real world. Very comfortable, very natural feeling. It's really quite an experience you have to see to really understand. Uh-oh, looks like PowerPoint crashed. We'll get that restarted in a second. But what's really important about the light field technology, being able to show all these focal planes is important, but what's most important is it enables new types of user experiences. So when you guys think about these type of AR and mixed reality applications, what are some of the applications that you think about? You know, a lot of our customers think about things like, I want to have a virtual conversation with somebody standing right next to me. I want to interact with them with my own hands, right? I want to pick up an object and actually touch it. Because of the close proximity of these type of experiences, that's not possible today. And this is one of the reasons why products that are out there today are not successful, because people can't build the type of experiences that they want. You know, this is a good example. I want to be able to see a virtual image of my child sitting next to me, and we can interact with an object with our own hands. I want to be able to look at more intuitive user interfaces, user interfaces that I can touch, that I can feel, that I can overlay on top of real-world objects, such as my hands or other objects. I want to be able to manipulate data, new types of controls and user interfaces. You know, touching interfaces, sliding things, controlling things with my own hands, having virtual objects that overlay on top of the real world, like this car on this table. This is only possible because we can deliver images the correct way. All the other technology to create experiences like this are already there, but the displays are the biggest limiting factor today in the industry. So in our demos, and you can actually see, if you do some research, you can find a lot of articles around our technology, we show a lot of different elements of these type of experiences in our labs. One of the neat things that we've also been able to do is not just an optics and display solution, it's also a content and computer processing or graphics processing solution, where we've developed the technology such that it can work with any graphics engine today. Where today we focus on Unity, and what that means is all Unity content today is compatible with their light field technology. So you don't have to go out and create new content. Everything out there today already works, and that becomes really great for people who want to create content on our platforms. Additionally, it's very low compute power. So not only can it run on PCs, but as well as mobile devices, and that's really important for a lot of different applications. So at the end of the day, light field is a very technical term. Hopefully I did a good job explaining it to you guys. But the most important thing about light field is not the technical details behind it, but it's the fact that light field can truly enable the experiences that people ultimately want to have in the industry, right? Both on the enterprise side and the consumer side. It's really one of the major limiting factors to why we haven't seen the proliferation of these type of devices. And speaking of that, I want to talk a little bit about where we think the industry is at today. Where we've seen a lot of fun little gadgets and prototypes and a very small number of products out there, but we're about to get to this point, which looks kind of funny, but the point is we're about to have a device that has real use, right? We're about to have a device that, yes, maybe it's a little clunky, maybe it's a little bit large, maybe it's not ready for the consumer mass market, but these devices are going to have a real place in the industry and they're going to solve real problems. So we're basically at the brick phone phase, where this brick phone was adopted by real enterprise customers and had real function and real use. This is where we're going to be at, the industry is going to be at in 2018. But what's really exciting is we see a clear path in our labs and our technology where we see the light at the end of the tunnel. We know how to get to the smartphone phase. And this path took about 10 years for the smartphone industry. I think it'll be a little bit faster in our industry. So I'd be really surprised if in a decade from now that most of you don't have some sort of wearable mixed reality device. It's pretty shocking, but it's happening very fast. And we can see some major strides in the industry toward this, where a lot of you probably have things like the iPhone, and Apple released ARKit in iOS 11, which puts augmented reality in your smartphone, in your pocket, for a couple of 100 million consumers today. And Google is following suit very closely with AR Core. And with AR Core, is going to boost the number to about 800 million consumers by the end of next year. So when you think about today, we're at a point where there are very few consumers that are using this stuff. But a year from now, it's going to be about 800 million consumers that are playing with augmented reality in their pockets. So I would encourage all of you, developers and enterprise leaders here, to make sure you have an AR strategy and what you're going to do in this space. You can start with the smartphone space, which is really great, but make sure you can step toward and evolve toward that wearable space. And what I want to end this talk with, my last slide, is I want to show you an example of my daughter, who at this time was only 4 years old, in one of our Lightfield prototype headsets. And what she's seeing here is actually she's running around the room and she's seeing fish swimming all around her. And they look so realistic that she's trying to reach out and grab these fish because they feel like they're right in her hands. And this is part of the Lightfield technology that makes it such a compelling experience. And she's actually saying here, I feel it, but it's not really there. And that's pretty exciting for us. So I'll say that I'm incredibly excited about where the industry is going. It's coming much faster than I think most analysts and most people on the outside are seeing. I think within the next 2 years or 3 years, we're going to see a ton of devices hit the market. They're going to be thinner and lighter with light field technologies, with incredible content. So that's what makes me excited. All these great types of use cases and experiences that people are going to have. But the one thing I'll say is, I'm also very cautious about the type of experiences that we're going to have, specifically around things like data ownership, privacy, user intent. All these things are kind of tricky things that have to be navigated. They have a lot of value that they're going to provide to us as users, but as always, as we have a new platform, we need to understand the pros and cons of a lot of stuff on these platforms. That's it. Thank you very much for having me.